Hi guys, I hope you're having a great day today. This is going to be broken into two parts. So first of all, this is the 832 part 2 using factoring and patterns to solve polynomials. So the first thing we're going to talk about in this first video is the 3 different factoring patterns that you guys should have written down, know how to use, especially when you go to do the practice. And then the second video, I'm going to show you how to use these in order to solve polynomials. Okay, so we're going to start with this first one. And hopefully you guys are really good with this one at this point because we've been doing this since first semester. So this is the differences of two squares. So for example, this is a squared minus b squared. And then we want to factor that into our two parentheses. So you know you have your two parentheses over here. So this is the one where I know I can take the square root of each of these things. So when I do the square root of a, this becomes a, and that goes in the first part of my two parentheses. This becomes a and a. And then when I do the square root of the second one, the square root of b squared becomes b, so then that goes in the last part. This is b and b. And then what you do is you just have one be a plus and one be a minus. And then this is your guys' final factor. So let's just make this a color. And then that's how you factor your differences of two squares. So let's do 2 examples. First example is 4x squared minus 25. Okay, so first thing you do is you do the square root of each of these. And these have to be square rootable for you to do this problem. So the square root of 4x squared is 2x, because 2x times 2x becomes 4x squared. And then the square root of 25 is 5. So then what we do is we just write our two parentheses. You know, the 2x goes in the front part of both of your parentheses. The 5 goes in the back. And then all you have is 1 is positive and 1 is negative in the middle, and then that is your factors for this. And you guys are done. Okay, and then they could get a little bit meaner, and they could be like this, where you have 3x squared minus 12. Now, if I tried to do the square root of each of these, I can't do the square root of 3 and I can't do the square root of 12, so I'm kind of stuck. The first thing that you would want to do in these is see if there's a greatest common factor. So I think there's a number I can divide out of both of these. So I can divide this by 3, and I can make this become 3. If I do 3x squared divided by 3, this becomes x squared. And then negative 12 divided by 3 becomes negative 4. Now this middle part becomes my differences of squares. So you're just factoring out a 3 to begin with. So I'm going to do the square root of this and the square root of this. So square root of x squared is x. Square root of 4 is 2. So then I can factor this into, the 3 has to stay in front. Then I have my two parentheses. The x goes in the front. The 2 goes in the back. And then remember the signs are plus, minus. And then that is going to be your final factor for this one. Now, the one thing that you do have to make sure that you are aware of is that this has to be a minus sign in the middle of these two things that are perfect squares. That's why it's called a difference of squares. If it's a plus sign, you can't do this pattern. It doesn't factor. So that's one thing you want to be careful of. Okay, next thing we're going to do is we're going to do differences of cubes. So differences of cubes looks like this, where you have a cubed, it's differences, so it means minus, b cubed. And this is going to be really similar to what we did in the last one, but instead of doing square roots, you're going to do cube roots. So these things should be things that you can do the cube root of, meaning what do you multiply 3 times to get the inside number? So I know if I do a times a times a, I get a cubed. So the cube root of a cubed is just a. And then if I do, let's keep this color coordinated here, the cube root of b cubed, this is b, because b times b times b 3 times give me b cubed, okay? And then what you do is there's this constant pattern. So you have a small parenthesis and then you have a big parenthesis every single time. And in your small parenthesis, you take the a and it goes in front, and then you take the b. And then if this is a minus sign in the middle, the sign in the middle of this first parenthesis is going to be a minus. So the cube root of this is a, that goes here. Cube root of this is b, that goes here. And then since this is a minus, this is a minus. Okay? And then what you do for the second part is you take whatever this a value is and you square it. And then you add to it your a times your b. And then you add to that your b squared. Okay, so that's how you guys write out these final answers, is you do cube root, a minus b, because that's a minus. Then you take whatever this is and square it, it goes here. You multiply these things together and it goes in the middle, and then you take b and square it and it goes at the end. So let's do a couple examples of this. So the first example we'll do is 8x cubed minus 27. Now remember, it has to be a minus for it to be a difference of cubes. So this is a minus, differences of cubes. And then we can also do the cube root of each of these things. So first, let's start by doing the cube root. So if I do the cube root of 8, that becomes 2 because 2 times 2 times 2 becomes 8. So this is 2. Oops, let's make our color coordination happen here. So this is 2, and then the cube root of x cubed is x. So the cube root of 8x cubed is 2x. And then the cube root of 27 is 3, because if you do 3 times 3 times 3, you get 27. Okay, so then what we do is we just plug this into our equation here. So your first parenthesis is going to be 2x minus 3, because up here it was your a, whatever this is, the cube root of this, and then your b, the cube root of this. So a minus b here. And then your second parenthesis is going to be this a value, which is your 2x squared. This is a plus. And then you're going to do your a value, so your 2x, times your b value, which is 3 in this one. And then you're going to add to it your 3 squared. Okay, and then you just want to simplify this. So we're just going to take this and simplify this a little bit more. So this first one stays 2x minus 3. This second parenthesis right here, if I do 2x squared, that's just doing 2x times 2x. So 2x times 2x becomes 4x squared. And then when I multiply 2x times 3, this becomes plus 6x. And then plus 3 squared is 9. And then this is going to be your final factor that you guys need to get to so that we can eventually take that and solve in the next problem. Okay, let's do one more, and then we'll do the last factoring pattern, which is going to be your sum of cubes. So let's do x cubed minus 1. So remember, first thing you do is the cube root of each of these. So cube root of x cubed, we know is x. Cube root of 1 is 1, and then it is a minus sign in the middle, so you know its differences. Okay, so then we just do a, which is x, minus b, which is 1. And then you take your a squared, so x squared, plus a times b, so x times 1, which is just 1x, plus 1 squared, which is just 1. Okay, and then let's just make this look a little bit nicer. So this is just x minus 1, x squared plus x plus 1. And then that is going to be your full factor, and you guys know that you're done. So just plug it in whenever a and b are. Remember, you take the cube roots of each of these. Okay, so the thing about cubes is you can have them be positive or negative in the middle. So this one is difference because it's minus. There could also be a sum of 2 cubes. So this means that there's a plus in the middle. So this looks like this. We have a cubed plus b cubed. Now we do the same thing. You're going to do the cube root of these things, but notice the difference is that there's a plus sign in the middle. So let me kind of move that over so we can see that. So there's a plus sign right here in the middle, and we can do the cube root of each of these things. So remember, the cube root of a cubed is just a, cube root of b cubed is just b, and then the pattern is almost the same. The only thing that changes is positive and negative signs. So this is still a and b, but since this is a positive sign right here, this is a positive in this first parenthesis instead of a negative, like in the one up here. So they're very similar. This is a negative, this one was a positive. And then you're still going to have your a, whatever this is, squared, but now this is your minus sign, minus your a times your b, and then this goes back to a plus whatever your b value is squared. So very similar to this one. The only thing is this is a minus and this is a plus, and then the middle one, this is a plus and this is a minus. So the way I remember that is since the minus is in the middle here, it has to be in the middle of your first parenthesis, the rest are positives. Since this is a positive, their first parenthesis has to be positive, the next one's a negative, and then it goes back to being a positive. So however you need to have that memorized, you can also seriously write these down. You don't need to have them memorized at this point, you just need to know how to use them. Okay, let's do 2 last examples. So let's do 27x cubed plus 125. Okay, so remember, first thing we do is we do the cube root of each of these things. We notice there's a plus in the middle. So let's see, we know the cube root of 27 was 3 because 3 times 3 times 3 is 27. Cube root of x cubed is just x. And the cube root of 25 is 5 because 5 times 5 times 5 becomes 125. Okay, then we plug it into our parentheses here. So this becomes 3x, and 5. And then we know the sign in the middle is positive because the sign right here is positive. And then we know that we take the a value and we square it right here. So 3x squared. And then this becomes a minus. And then we take a times b, so 3x times this 5, plus the b value, which is 5 squared. Okay, and then we do need to rewrite this a little bit. So your first parenthesis is just going to be 3x plus 5. And then if I take 3x and square it, 3 times 3 becomes 9, and then this is 9x squared. And then negative 3x times 5 becomes negative 15x. And then 5 squared is 25. So then this is going to be your guys' final factor for that one. So then you're done right there. Okay, let's do one last example. Let's do x cubed plus 8. So first thing you do the cube root of each of these. Cube root of x cubed is x. Cube root of 8 is 2. And then we just plug it into our formula. So this becomes x. This is 2. And then it's a plus sign in the middle because we know this is a plus, so this has to be a plus. The second one is going to be whatever this a value is squared, so x squared. This is now a minus a times b, so x times 2, plus your b value squared, so 2 squared. And then you just rewrite it so it looks a little bit nicer. So this becomes x plus 2. This is just x squared. This is negative 2x, and then this is 4. And then that's your guys' final factor. So what we're going to do in the next video is we're going to take this and we're going to solve the polynomials down using these two because we know how to solve quadratics, so we know how to solve this. So stay tuned, make sure you watch the next video so that you guys can use these patterns to actually solve polynomials, and then you'll just do some practice on it for the homework.